For the ideal independent voltage source, we have different symbols to represent ideal independent voltage sources. So this one here with a little sine wave, that is the symbol that we use for an alternating current voltage source. Or an AC voltage source. These two symbols we use to denote a DC voltage source or a direct current voltage source. And in fact, this voltage source over here, this drawing, is usually used to denote a battery. And just like for the ideal independent current source, it produces that voltage across its terminal irrespective of what is connected to it and for how long it's connected. So if we plot it against time, the ideal independent voltage source will produce the same voltage irrespective of how much time passes. And if we plot it against current, it will produce a constant voltage irrespective of how much current is drawn by the circuit. And of course, if it's an AC source, it will produce a constant sine wave irrespective of what is connected to it. But that brings me to some more important jargon. So if we look at the AC source, which typically produces a sine wave, then some other important terminology to know. Okay, so this is a voltage, and this is time. Let's say that this is at 4 volts, and this is at minus 4 volts. Then it's important to note that this voltage is called the peak voltage, V peak, and that is equal to 4 volts in this case. But the voltage from here to here, that is called V peak to peak, the peak to peak voltage. And V peak to peak is equal to 8 volts because we measure it from the one peak of the sine wave to the next, to the valley of the sine wave. Regarding polarity, it's similar to what we saw with the ideal independent current source. So if you have a voltage that's drawn like this, and that is minus 6 volts, then that is equivalent to drawing it like this. You flip the signs around, and then you can also change the sign of the voltage. So this is 6 volts, and the polarity of the voltage source has been changed around. And it just is easier when you do more complex analyses to work with positive numbers, so it's less confusing. Note that the ideal independent voltage source and the ideal independent current source is just a useful model for what we see happening in circuits.